All right, this is section 6.3 actually, even though this is going to be your starter for tomorrow. I'm just showing this to you. I want you once again to bring this in tomorrow and start working on it, and we'll kind of talk about how to attack a problem like this at the beginning of the day. But 6.3 is we're going to solve multiple angle equations. So this is where you're going to see double angles and triple angles and a whole bunch of stuff in there. What you're going to notice, though, is it's not much different than what we've done before. It's just a little twist at the end. Okay, so the first thing you always want to do with any of these, okay, now I'm finding it between 0 and 360, you need to get the trig function by itself. Don't worry about this 2 theta until the very, very, very end. So I want you to solve this like you did on every other section and kind of ignore the 2 theta for a second. And if you guys would draw your triangle, or where are we, of cosines negative, left, so 2 and 3. This will be your negative root 3, and then this will be your 2, 2. This will be a 1, a negative 1. So I have a 30-degree angle in each spot, right? So if I have 30 degrees, that means my 2 angles, if I would have done this, if the 2's not there, you would say theta equals 150 degrees, and then you would say theta is also equal to 210 degrees. But here's the kicker. It's 2 theta today, all right? So instead of actually getting answers originally from 0 to 360, technically it's 0. And if you multiply everything by 2, you have to go up to 720. Now that's the original one. So here's how I solve this. And before you guys divide everything by 2, because in the end you need to get theta by itself, you need to add your period essentially a second time. You're going to go through a second round. And if you guys would go around your circle twice, this one would also be equal to 150 plus 360. So 510 degrees. And then this one, if you add 360 to it, would be 570. Okay? If I had this as a 3 angle, you would do another one and keep adding 360 to everything's based off of your original 2 answers. Okay? Then I add my period, so in this case, my 360 over and over and over again. And then what you're going to do is you're going to back it up. Now you divide everything by 2 and you get it back to your original distance. So I'm going to divide everything by 2 in every equation that I made. And those will end up being your answers to this problem. Okay, so this is 75 degrees. That's one of them. Okay, if I do the one that it's related to, 255 degrees is another one. Divide this one by 2. 105 degrees. And then this one, 285 degrees. Okay, so what's happening here? Technically, you guys look at this, and you're going to know that your period is actually just 180 degrees. But I want answers for the whole circle. So instead of you kind of backing this up and figuring out what you need to add, now, yes, you could add 180, and you could work on it that way, but I like doing the original ones. Keep adding 360. It's consistent. It's not going to change. It's going to be easy when you do all of them. And then you divide by 2 to all of them at the very end. Okay? So this is one example. If you're just mind-blown right now, that's okay. Let's keep on working. Let's see what we can get out of this one. Okay? So if I give you sine of 3 theta, okay, so your b value is now 3, equals negative 1, okay? How many answers should you get? 3 times around the circle, right? So now if I would do this, if I just do this around the circle the first time, if I take sine inverse, what do you get? Where's sine at negative 1? You would say 3 theta equals, okay, negative 1, now I want degree measures. Where's sine? Where's the y at negative 1? Just here. Okay, that's the only spot. So that would be what? 270 degrees, right? But how many times do you guys need to go around the circle? 3 times, okay? So what I would like you to do is let's write the second time around the circle. If you went around again, you'd have to go 360 more degrees. So I would add 360. So I'd say 3 theta equals 360 plus that is what, 630 degrees. And I technically have to go around one more time. So the third trip around, 3 theta equals 990 degrees. But as your theta all alone, have you solved for all of your angles? No. Now you divide by 3 to each of them separate. So this theta would be 90 degrees. Okay, because it's going to sandwich it in. And I could show you this on a graph in class if you want. Divide this by 3. It would be 210 degrees. And then divide this one by 3. And if you notice, when you get back, they're all within 0 and 360 degrees. Once you solve for theta, I'm just adding my period on and then backing them up. Okay? So there's another example of how, but there's only 3 answers because in the original circle, we only had 1. On this one, my original one had 2, so then it multiplies to 4 of them. All right, since this one technically should have had 6 answers, but since there's only 1 in the original one, you only have 3. Okay? Oh my goodness, I have a, let's see. What will this look like? Okay, what formula does this look like? I believe this is a sum and difference formula. Okay, a sine, cosine plus cosine sine. Sine, cosine plus cosine sine. That's the sum of a sine. So on your formula sheet, this right here is essentially equal to sine of A plus B. Okay? That's equal to -1. What's your A? Here's your A. Here's your B. So sine of what? 2x plus 3x. So that's sine of 5x equals -1. Ish. But notice how I didn't give you between 0 and 360 here? I gave you, I want all of them forever. That's every single one of them. What's nice about that? You guys just need to find me the angle measures the first time around the circle. We'll worry about the 5 in a second. Okay? So I'm going to take sine inverse of -1. We've done this already. Where's the only spot where sine is -1? Straight down. So if you went around the circle one time, you actually would only get one answer, right? So I would end up saying that 5x equals, that one answer is 270 degrees. How would I get every other answer? Technically, I should do this 5 times. I should add 360. I should add 360. I should add 360, right? I can add 360 degrees however many times I want. I put an n in there, okay? Now this is what I would use if I wanted degree measures, and if I would solve, I divide everything by 5. So x would equal 54 degrees plus 72 degrees times however many times I wanted to go around the circle. This is if I wanted degrees, but radians is actually, this is actually easier in radians. Okay, what is that original 270? So this is what my actual answer is for radians. 5x would have equaled, okay, once again, if I go straight down, what's my radian measure straight down? It's 3 pi over 2. Plus, what do I add to get back around to that? 2 pi instead of 360. So I would go 2 pi n. Okay, now how do I get x all alone? I divide by 5. Maybe I'll do that in a different color. If I divide everything by 5 or multiply by 1/5, I would get x would equal, let's see, 3 pi over 10 plus 2 pi n over 5. Okay? So instead of you actually listing them all out, you can just simply do them all but with that letter in there, or that variable. So there's another example, and don't worry, we will practice plenty more of these as we work on these in class. Last one. Okay, 2 sine squared, triple angle, minus sine of the triple angle, minus 1 equals 0, okay? Just treat this as a variable for now. Don't freak about the 3 theta. You guys can factor this, okay? So if you guys factor this, I would end up factoring this as how? 2 sine, you know what, I'm even going to put an x in there for right now. And then just sine x, and a 1 and a 1, and you would have what? Minus and a plus. Okay? So if you guys would actually figure this out and solve for this, now what is your x? It's a 3 theta. Okay? You could say, subtract 1, divide by 2. Sine of 3 theta equals -1/2. And then sine of 3 theta equals 1. Okay? That's not so bad. Now how do I go about doing this 3 theta business? Now I want all of them again. I don't need to do them all separately. I don't have an interval in here. I can just do that n idea like I did last time. But in order to do that, you guys need to give me both of your possibilities the first time around the circle. So I need to still go back to my original thought process. Where's sine negative? Here and there. Negative 1, 2. Negative 1, 2. That's a root 3. There's a negative root 3. So I know that's a 30. And this is a 30. So the first one is 210. So I would say 3 theta equals 210. Okay? And then the other one would be 3 theta equals, what, 330? Now, if I want all of them, technically I should have to keep going and I should get 6 answers, but in this case I can just stop and I can do all of them. Okay? What do I add to get back to this guy? 360 degrees, however many times I want. Likewise here, I can add 360 degrees, however many times I want. Second time around, third time around, fourth time around, and you keep going. Now, if it's all of them, I keep going as many times as I please. So now to solve for theta, I divide everything by 3. So theta ends up being just theta, 100 and... I lied, not 100. This is 70. 21 divided by 3 is 7. So 70 degrees plus 120 degrees N. That's one option. Divide all these by 3. Theta equals 110 degrees plus 120 degrees N. And then don't forget this guy right here. Where is sine equal to 1? That's only straight up. So the only one I can get for 3 theta is 90 degrees, and I can get back to 90 going around the circle one full rotation, which is 360 degrees. However many times I want. So that's where the n comes in. And then likewise, just like I did on the other two, divide them all by 3. So theta equals 30 degrees plus 120 degrees N. Oh man, that's finding all the degree solutions. I don't give you the interval to do that with. And once again, like I said, if you're lost, that's quite all right. We will practice these. This is the assignment that you can start working on. And then tomorrow in class, we will try to do some whiteboards. And I hope you all have a wonderful day.